Hello guys, welcome back to Maths on African Motives, still on Mathematics and 5 on the question paper, which was written in February 2022. We are going to try by all means to focus on question number 5 and question number 6 as last part, as I saw that it's actually you're having 7 marks on question 6, so you can just combine with question 5. All right, we are going to quickly rush through the questions. We are given 5.1 to evaluate the definite integral given the limits. So there we're supposed to check which integral are we supposed to use and how to apply that integral. All right, so I'm just going to use this side here. So this was 5.1. So we are given the integral of 8. This is 8 cos. Let me try and reduce this a little bit here. All right, so it was 8 cos 2x. So this is 8 cos of 2x, everything over the square root of 9 minus 5 sine 2x. All right, so this is what we had here. All right, and we're given the limits from 0 to pi over 4. So whenever you're given the limits, that means we are supposed to apply the upper limit minus the lower limit. All right, so this is the integral that you're given. By looking at the question, we have got some familiar things that we have here in the numerator and the denominator. So you can actually try by all means, at least try to apply the substitution method here. As for me, I'm just going to introduce the substitution part as this part under the complicated part, but that is under the square root here. At least it can help me. So let u be equal to 9 minus 5 sine of 2x. So I'm going to use this part. Remember, on your substitution method, you're supposed to find du dx so that we can substitute in place of dx here. So derivative of 9 is a constant, so it's going to be a 0 there. And we've got sine. Remember, sine changes into cos, but this 2 is going to multiply 5. So it is going to be 2 times 5, which is negative 10 cos 2x, because it was supposed to be 0 minus, so it's going to be negative 10 cos 2x. So by finding dx, we can just cross multiply, because this is same like over 1. So 1 times du, that's du, which is equal to negative 10 cos 2x by dx. We are multiplying, cross multiplying like this. So this is going to be dx. So to find dx, as we can see, we have to divide by cos 2x, negative 10 cos 2x, negative 10 cos 2x, so that this can cancel, and we have the expression for dx, which can be given as du over negative 10 cos of 2x. All right, so that means we are going to substitute. Remember, this is substitution method. In place of u, we are going to substitute this. In place of dx, we are going to substitute this expression. So that means here we are going to have this as the integral. You can even change the limits if you want. In this case, that is the best way, so that we do not come back. We do not come back and introduce this x again. We can change the limits. How can we change the limits? We just have to substitute, because we've got u here being equal to 9 minus 5 sine 2x. So we're going to substitute the first, which is the upper limit, when our upper limit is pi over 4. But make sure that your calculator is supposed to be in radians. All right. So if we are to substitute pi over 4, this is going to be the first limit, which is the upper limit, which is u2. So this is going to be 9 minus 5 sine 2x. Our x there is pi over 4. So it's 2 by pi over 4. And let's see what you're going to have there as our u1. All right, so you can change the limits, or you can leave it like that. Then you have to substitute x later on. You are going to see the difference later on. All right, so here I just have to change here to radians, which is 4. That's my calculator. There must be error here. There must be this error here to show that you are in radians. So this is 9 minus 5 sine 2 times pi over 4. So pi over 4 like this. You can close the bracket, which is 4. So here we are going to obtain a 4. Then we have got u1, which is 9 minus 5 sine 2 times the lower limit here, that's as 0 there. So we're going to substitute as 0, which is just as 0. So it's 9 minus sine. So we do know that sine 0 is as 0. So this is going to be 9 minus 0, which is 9. All right. So by me looking here, we can see that there's an interchange which is happening in terms of the powers. This one, it's in terms of the limits. Okay, so we are going to use the upper limit as 4, the lower limit as 9. So that's what you're going to have here. So this is going to be the integral of, here we said we are now having a 4. This is now a 9 in terms of the limits. Since it is now in terms of u, because we are going to substitute that u part. So here we are going to have 8 cos is going to remain as it is. That is 8 cos 2x over the square root of 9 minus 5 sine is the one that we introduced to be represented by u. So this is going to be the square root of u by dx. Our dx is the one that we got, which is du over negative 10 cos 2x. All right. So there's something that is happening here that we can clearly see that we've got a cos 2x here. And 8 over 10 can reduce by 2. This is going to be 4 by 2. This is going to be negative 5. So we can take out the negative 5 out of them. Negative 4 over 5 because it's going to be 4 over 5. 4 over minus 5. So 4 over minus 5 is same as minus 4 over 5. This part of 4 and this part of minus 5 outside of the integral. Okay, we've got our limits 4 and 9. If we are to do that, we are going to see that here we are going to remain with 1 over the square root of u. And what we have on 1 over the square root of u, like this, 1 over the square root of u. Remember, square root is same as to the exponent of a half. So this is 1 over u to the exponent of a half. And we know that 1 over simply means to the exponent of a negative. So this is same as u to the exponent of a negative half. So we've got u to the exponent of negative half du, like that. So it now becomes easier because it's just integrating u to the exponent of half. Remember, integration, you have to add 1 there. And if we are to add 1, that's negative half plus 1, which is a half. So we are going to have this expression as negative 4 over 5 times, we have integrated this, we have got u to the exponent of a half, if we add over a half, all right, with the limits 4 and 9. All right, I want us to check something here because we are actually like multiplying. This is same as 1 over a half. And 1 over a half is the inverse of a half, which is 2. We can even divide on your calculator. 1 divided by a half, which is 1 divided by a half, like this. You are going to obtain 2. So that means here we are having 2 times negative 4 over 5. Okay, so if we multiply this to negative 4 over 5, this is going to be negative 8 over 5. All right, so we can write that outside of the bracket as negative 8. Is that so? Yeah, negative 8 over 5. So this is going to be negative 8 over 5. Whatever that we have got u to the exponent of half, which is going to remain here with the limits that we are given as 4 and 9. So these are the limits 4 and 9. All right, so since we are having u, there's no need for us to substitute the x because we introduce the limits of u here. So we're going to remain with that. But if you are to introduce back this x here, this u, in terms of x, the one that we had here, then we are going to use the normal limits as they were pi over 4 and 0, but here we are going to remain with these limits of u. So that means we are going to substitute the upper limit minus the lower limit. So this can be written as negative 8 over 5. All right, so if we substitute the upper limit, which is 4, it's 4 to the exponent of a half, minus the lower limit, which is 9, which is 9 to the exponent of a half. So this is what you're going to have. So you can simplify this direct on your calculator, or you can simplify stage by stage. I don't know which is best for you, but here I'm just going to simplify everything direct. So we've got 4 to the exponent of a half, which is 1 over 2, minus 9 to the exponent of a half. So this is 9 to the exponent of a half, which is 1/2. And we can close our bracket here. All right, we are going to obtain 8/5. So 8/5, all right? So anyways, this is 8/5, of which 8/5 can be written as, let's change this, 1,6, or it can be 1 3/5. I don't know which one is best for you, or you can write it as 1,6, but that is what you're going to have at the end. So that was the integral that we were given. As you can see, guys, the substitution together with the change of limits on the same question. As you can see, we had to use substitution and we had to apply also the change of limits on this part, so that it helps us to avoid a lot of working or a lot of calculations into the question. All right, so that's what we had. We're going to move on to the other part of the question, which is on 5.2, where we are given two curves. The curve of y is equal to x squared minus 1, and the curve of y is equal to x plus 1. And from these two curves, we are asked to calculate the coordinates of the point of intersection, as we know that at the point of intersection, these two graphs are equal. So if y and y are equal, it means x minus 1 squared is equal to x plus 1. So that's an equation that you're going to formulate. So this is 5.21. So since y is equal to y, it means x minus 1 squared is equal to x plus 1. Okay, this was x minus 1, and this will be equal to x plus 1. So you formulated an equation in terms of x. You can solve here using your identities. You're going to obtain x squared minus 2x plus 1, or you can expand the brackets properly. X minus 1 into x minus 1, you expand, you get the same answer, all right, which is equal to x plus 1. So transpose to the left-hand side, the x here is going to be negative x. So that is going to be x squared minus 2x minus x, which is now negative 3x. Then we transpose the 1 to this side, is going to be negative 1. So it's 1 minus 1, that's a 0. So it's going to be equal to 0 there. So how can we find x? We can factorize, since x is common, we can factor out x. X squared divided by x, that is x, minus 3x divided by x, that's negative 3, is equal to 0. So each of these from the 0 concept must be equal to 0. So x is equal to 0, or x is equal to 3. Minus 3 to that side becomes a positive. Remember, this is a point. We are calculating the coordinates, which is the point. So you're supposed to substitute the values of x that we got. When x is 0, you can substitute into any one of these. Y is equal to x minus 1 squared, or y is equal to x plus 1. Since we said at the point of intersection, these two are equal. So if x is equal to 0 here, as you can see, 0 plus 1, that's a 1. So which means y is going to be equal to 1. If we are to substitute x as 3 here, that's 3 plus 1, which is 4. So which means y here is going to be equal to 4. So therefore, the 2 points that we are going to have, it's 0 versus 1. So we are going to have 0 versus 1. And the other point, x is 3 and y is 4. So we've got 3, 4. All right, so these are the 2 points that we are going to have at the point of intersection of the two graphs. All right, then 5.12, we are now asked to sketch the graphs so that we can have the area. Okay, the graph to show the enclosed area of the given graph that we had and the representative series. Definitely, we have to show the point of intersection of the two graphs. Okay, sketching the graph of y is equal to x minus 1 squared. This is what we had here. It simply means we've got one solution at x is equal to 1, because we're given this is x minus 1 squared. Remember how to sketch graphs, guys, from your maths N4. All right, so that is where we are taking this. So this is 5.22. Y is equal to x minus 1 squared shows that there is one solution at x is equal to 1. So that means we can substitute that, and the y-intercept when x is equal to 0, it's at y is equal to 1. So the y-intercept is at x, is at y is equal to 1, and the x-intercept is at x is equal to 1 again. All right, so that's it. At point x is equal to 1 and point y is equal to 1, that's where our graph is going to cross the x-axis. It's not going to cross, actually, it's going to have a turning point at 1, because it's having a solution and also a turning point at 1. So it's supposed to be like this. All right. So that's the graph of y is equal to x minus 1 squared. All right. Having this graph, we now need the graph of y is equal to x plus 1. So as you can see from this graph, if we are to determine the x-intercept, that's when y is equal to 0 here. X is going to be -1. If you transpose, -1 is equal to x. And if x is equal to 1, y is equal to 1. So we've got x, which is -1, and y, which is equal to 1. So there is a 1, -1, we can just say there, and 1 there. So I am going to draw the line so that we do not confuse it. But this line is supposed to pass through 1 like that. So this is how our graph is supposed to be, passing through the point 1 at this point and passing through -1. All right, so as we saw that on the point of intersection, there was 0, 1 here. There was 0, 1, and 3, 4. So definitely this is our 0, 1, and this is our 3, 4. So definitely it means at this point, that's where we have our 3 and y is 4. So this is another point of intersection 3, 4. And this is the turning point of the given graph for that one. So the representative strip is supposed to be this way. As you can see, guys, this is where we are having our representative strip with respect to x. And we say this is the graph of y is equal to x plus 1. All right, like that, okay? So simply, that's what we had on the sketch. I don't know if we left anything, but this sketch, I think it's clearly presented or given. So your area is supposed to be taken from this region that is in between this region here that I'm indicating there from 0 to 3. All right, then on 5.23, they are now asking us to calculate the magnitude of the area, which is of question 5.22. All right, so the magnitude of area, these are two curves, and we can see that from these two curves, this one is on top. So this we can just refer to as y2 or y1. I don't know which one is best for you, the one on top and this one below as y1. Since our area can be given as 5.23, so our area with respect to x can be given as the integral of the given functions, but we are supposed to subtract the one on top minus the one below. So it's top minus below. This one on top minus below. So this is your top and this is the bottom one. So you subtract the bottom one from the top. So our area, remember, is the integral of the given function. We've got a and b. So it's going to be y2 minus y1 with respect to x. Okay, of which we can substitute the values a and b. That's a, the lower limit of 0, b, the upper limit of 3. So y2, that is the top one of y is equal to x plus 1. So it is going to be x plus 1 minus y1, and y1 is this one of x minus 1 squared, of which we expanded this x minus 1 squared. Remember, we expanded here. We got x squared minus 2x plus 1. So that is the one that you're going to write, the expanded one. Okay, so you're going to subtract x squared minus 2x plus 1 with respect to x. All right, so the brackets is to show that we are subtracting an expression there. So this is an expression that you're subtracting. So the limits is from 0 to 3 on the point of intersection. That's where we are having these limits from. So that is the expression that we are going to use here. So area is the integral of, let's simplify whatever that we can here, expanding brackets. We are going to have x plus 1 minus times x squared, that's minus x squared, minus times minus 2, that's plus 2. So this is going to be plus 2x minus times 1, which is -1 with respect to x. All right, which is the integral of, let's see, x here is going to be x and 2x. So the same as 1x plus 2x, that is 3x. So you're going to have 3x, 1 here minus 1, that's a 0. And we are just left with minus x squared. So this will be minus x squared with respect to x. So that's it. We have a simplified version of the question that we can actually use to integrate here. So now we can integrate, substitute the limits, we have got the area. So our area with respect to x is going to be, let's integrate 3x. This is same as 3x to the exponent of 1. So you just have to add 1, which is 2. So it's going to be 3x to the exponent of 2. We divide by the new exponent, which is 2. Minus, we do the same here. We add 1, which is now 3. So it's going to be minus x to the exponent of 3 over 3. Then the limits from 3 to 0. So by doing this, we can substitute to obtain the values, the value of the area. So our area with respect to x, we have got the upper limit, which is 3. So we are going to substitute 3 in place of x. So this is going to be 3 by 3 squared over 2 minus 3 to the exponent of 3 over 3 minus the lower limit when x is equal to 0. So as you can see, this one will be a 0, a 0. So it's going to be 0 minus 0 there. All right, so this is the expression for the area. So use your calculator properly. Yes, it was going to give you something like 9 over 2, which is 4,5 square units. So area is measured in square units, or you can write this as square units, like 4,5 square units, or you can even write it as 4,5 units squared, like that. Still one and the same thing. All right, so that was the expression. That was the numerical value for the area, not an expression. This is the expression in terms of integral. Then we have got the numerical value. So it was a matter of substituting the values where it is proper, and also working with the formula also. That is what is important. All right, so we're going to check the other part of the question, which is on 5.24. So 5.24 is now calculate the volume of the solid of the revolution formed when the area in question 5.22 is rotated about the x-axis. All right, so this is area volume now, but still with the same concept, just like what we had on area. We are going to subtract y2 and y1 here, but now having a different format or a different formula, but we are going to apply the same thing, the same limits also. So I can even try to work it this side. It's even proper. Yeah, I can even try to work it this side. So this is 5.14. So the volume with respect to x is supposed to be given by the formula pi, the integral of having the limits a and b, but this will be y2 squared minus y1 squared with respect to x. We are going to square. If it was just y, you just have to square, but there are two functions. That is why we have to subtract. All right. So y2 is the same y2 that we had last time, which was x plus 1. So you have to square that x plus 1. So that means vx going to be pi. The limits are not changing. It's still 0 up to 3. Now we have to square y2. Remember, our y2 was x plus 1. So now it's x plus 1 squared. Minus y1, and our y1, we used the expanded one, which was x squared minus 2x plus 1. But we have to square this. All right, so that is the expression that is what you're going to have in this case. So as you can see, guys, there is a need for you to expand this and simplify as much as you can. Okay, so let's see where we are going to reach. This is going to be x squared plus 1. You can use your identities or just expand two brackets, x plus 1 into x plus 1. All right, you're going to obtain something like x squared plus 2x plus 1. All right. Whatever that we are going to get here, we are supposed to subtract what we are going to obtain from this bracket of x squared minus 2x plus 1. So this one, I'm going to expand it aside here. I'm going to expand it here. All right, let's try and expand it together here, guys. That's x minus 1. Okay, that was x squared minus 2x plus 1 squared, which means we've got two brackets, x squared minus 2x plus 1. All right, let's expand together x here, x squared and x squared. That is, we are going to obtain x to the exponent of 4. Then we've got x squared and minus 2x, which is going to be to the exponent of 3, minus 2x to the exponent of 3. Okay, we move on, x squared and 1 here, that is just x squared. So it's going to be plus x squared. All right, we are done with x squared. It is multiplied everything. We move on to minus 2x. So minus 2x has to multiply everything also. So it's minus 2x and x squared, which is minus 2x to the exponent of 3. Because we've got x and x there. Then minus 2x and minus 2x, which is going to be positive, negative and negative. So it's positive 4x squared, negative 2x, and 1 here, that's negative 2x. So we are done with negative 2x. We move on to 1. So it's 1 versus x squared, which is x squared. 1 versus negative 2x, which is negative 2x. 1 versus 1 here, which is a 1. Okay, then we can collect like terms. That's x to the exponent of 4. We have got negative 2x cubed here, negative 2x cubed here. So negative 2, that will be negative 4. So we are going to obtain negative 4x to the exponent of 3. We move on to x squared. This is 1x squared plus 4x squared, which is 5, plus also 1x squared. So it's 1 plus 4, which is 5 plus 1, which is 6. So it's going to be plus 6x squared. Okay, let's move on to x. We have got negative 2x here, negative 2x here. So negative 2, that's negative 4x. And we just have this one, which is left. All right, so that is what you're going to have from this expression. And that's what you're going to write here in our answer, the whole part that we got from that part. So we are going to subtract that whole expression. It was x to the exponent of 4 minus 4x to the exponent of 3 plus 6x squared minus 4x plus 1. That's what we got there. So we're going to simplify from there. So it's going to be pi, the limits 0 to 3. Okay, so by doing this, we are going to see that the negative is going to affect everything. So here it is going to be negative x to the exponent of 4, negative and negative, which is plus 4x to the exponent of 3, negative and positive, which is negative 6x squared, negative and negative, which is plus 4x, negative and positive, which is negative 1. So this negative is affected everything in the bracket. So now we can collect like terms. Okay, x to the exponent of 4 has got nothing to which goes with, so it's just going to be x to the exponent of 4. Same with x to the exponent of 3 plus 4x to the exponent of 3. We move on to negative 6x squared here. It has got x squared here, so it's going to add 1 and negative 6. So 1 minus 6, that is minus 5. So it's minus 5x squared. All right, we move on to 2x. It's 2x and 4x here. 2 plus 4, that is 6. So it's going to be 6x. We have got 1 here, 1 minus 1, that's a 0. So which means that one is not going to be there. All right, so this is what we are going to remain with. And it's for us now to integrate. So from there, we can have our volume. All right, so let's integrate, guys, whatever that we have here. Negative x to the exponent of 4. If we add 1, this is going to be 5. So it's negative x to the exponent of 5 over 5. Plus here, we are supposed to have something like, if we add, this will be 4. So it's supposed to be 4x to the exponent of 4 over 4. But this will cancel, which means we are going to remain with x to the exponent of 4. Here we're going to add 1. That is 3. If we add 1, it's going to be 3. So it's there's nothing that is going to change here. So it's going to be minus 5x to the exponent of 3 over 3. 6 here, we are going to add 1. This is 1 plus 1, which is 2. So it was going to be 6x squared over 2. 2 into 6, that is 3. So we are going to obtain 3x squared with the limits from 0 to 3. So that's what you're going to have at the end. So from the presentation, it simply is a clear presentation that we are going to substitute the values of x that we are given for the upper limit, which is the upper limit of 3 in place of x here. So this will be negative 3 to the exponent of 5 over 5 plus 3 to the exponent of 4 minus 5 by 3 to the exponent of 3 over 3 plus 3 into 3 squared. This is what you're going to have minus cross-checking here. If we substitute here, this is going to be a 0, a 0, a 0, a 0. So there's nothing that you're going to have. So it's just a 0 here. All right, that's you and your calculator, guys. Make sure that you apply your calculator properly on this one. We are going to obtain something like 72 over 5 pi. And this is volume measured in cubic units, or you can write units cubed, or as a decimal. It can be as a decimal. 45,238 8, 9, something like that. 8, 9, 3, 4, which if we round off is going to be 3, 9 cubic units. So like I said, you can write it like this, cubic units like that. All right, so that is the volume of the given part that is solid that is going to be rotated about the x-axis. So these are the calculations that you had. And not forgetting the expansion of brackets that we had here. You must clearly expand your brackets properly. Think that one is fine. So we are going to see the other part of the question, but as we can see, guys, this was pretty clear. All right, so I'm just going to remove some of the parts here. I think my pages, they are too much. Let me just remove some of these because we no longer need these ones. All right, on 5.3, we are asked to calculate the second moment of area of a circular lamina with radius of 5 centimeters. Take note, we are given a radius here of 5 centimeters about an axis through its center and perpendicular to the plane of the lamina. Okay. If we are given the radius, actually this is a circular part that we are given, because we are given a radius of 5, 5. This is minus 5, 5. This is minus 5. So it's actually a circle that we are having. All right. The second moment of area is given by the formula. So this is 5.3. Knowing that our second moment, is equivalent to r squared dA, which is the radius that we are given. But in this case, substituting the values that we are given, our area is this part of dA, which is given in terms of area, is 2 pi x dx, like that. So that means we are going to substitute our x, definitely r squared, that is the radius in terms of x, which is going to be x squared by 2 pi x dx. All right, so by integrating this, but before we integrate, we can just maybe collect like terms, x squared and the x here, which is going to be x cubed. So it's going to be 2 pi x cubed dx. So that means we can find our second moment of area here from the integral of this expression of 2 pi x cubed dx. The limits now is the radius. Remember, your radius is from 0 to 5, okay? From 0 to 5. So those are the limits from 0 to 5 because it's taken from the origin, okay, with respect to x. So the 2 pi can be taken out of the integral. We do not need this. When integrating, we just remain with x cubed with respect to x. So that's you guys and your integration. So moments, guys, N5 is direct. Most of the moments that you have, they are in N6. In N5, guys, this is what you need. So if you add 1, that's x to the exponent of 4 over 4. The limit's 5 to 0. So remember, upper limit minus lower limit. Upper limit is 5. So this is going to be 2 pi into the upper limit, which is 5 to the exponent of 4 over 4, minus the lower limit, which is 0 here. So that's what you're going to have. So from your calculator, if we are to simplify properly, this will be 625 over 2. This will be over 2 because the 2 and 2 cancel pi. Or as a decimal, can be 981,748, something like that. Okay, let's check the units of measurements that we are given. This radius was given in centimeters. So since this is the second moment, it is going to be centimeters to the exponent of 4 for the second moment. If it was the first moment, then it's to the exponent of 3. So that is actually what we had from this part. And as you can see, guys, it's a lot, but not that much as we revise on much questions. So I actually advise you guys to work on more questions or more revisions. It can be much easier than the way it looks right now by doing as much questions as you can. All right, so you're going to check the other part. Like I said, we are just going to try by all means to combine these two questions, question 6 and question 5. So question 6, we are given that determine the particular solution of this. Okay, the particular solution. Okay, as you can see, definitely we have to try by all means to separate these. We are given that y0 is equal to 1. That is when x is equal to 0, y is equal to 1. But you are supposed to separate here. So what can we do to separate this? Let's start by cross multiplying. We can cross multiply. That is going to be 1 plus 2y squared dy, which is equal to, if you cross multiply here, is going to be y cos x by dx. So this is be dx. So since here we just need x here, so you're supposed to remove this y. What is happening with y? Y is multiplying. So what are you going to do to remove this? We divide by y, both sides, we divide by y. So this can cancel. So we are going to remain with cos x dx on this side. But on the left side, we can see that here there's a need for us to separate this expression, because remember, a plus b over c is same as a over c plus b over c. So here we're going to separate. It's going to be 1 over y plus that other part. So we're going to have 1 over y plus, this will be 2y squared. It was supposed to be like this, 2y squared over y. As you can see, this can cancel, and you remain with 2y. So this will be 2y here. So this is what you are going to have as a single expression with respect to y. So this part only has y, this part only has x. So that means it's now possible for us to integrate both sides. And by integrating both sides, we are remaining with y here. We are remaining with terms of y, terms of x. So let's integrate 1 over y, guys. The integral of 1 over y, that one is definitely ln. So it's going to be ln y plus 2y is same as to the exponent of 1. So we're going to add 1, which was going to give us 2y squared over 2. So 2 and 2 will cancel. So we're going to have y squared, which is equivalent to cos. Remember, the integral of cos is the reverse. Sine gave us cos. So cos is going to give us sine x. So this would be sine x plus the constant of integration. So the particular solution, this part that we have, this is the general solution that we have. So to find out the particulars, that is where we get back to this information that we are given, that when x is equal to 0, y is equal to 1. So we're going to substitute in place of x, we are going to substitute a 0. In place of y, we are going to substitute a 1 and see what we are going to have. And remembering that ln 1 is a 0. 1 squared is going to be a 1, which is equal to sine 0. Sine 0, guys, that's a 0. So which means this will be c. So because we've got 0 plus c. So c is equal to 1. So therefore, if c is equal to 1, we are going to write this as ln y plus y squared is equivalent to sine x plus that c that we got, and we said our c is 1. So now we have the particular solution. Okay, so that was it from this part 6.1. I think if working with the differential equations is something that is direct, I just have to revise as much as you can. All right, so I'm going to remove this part so that we can be able to work out our 6.2 here, which is determine the particular solution. All right, this was actually wrong. This is not particular because we are not given the values of x here. So this is supposed to be the general solution, not the particular one. Okay, we do not have the values of x and y. So it was wrong asking there. Anyways, we are given that x d squared y dx squared is equal to this. So we are supposed to remove this x. How can we remove this x? We definitely have to divide by x each and every term. And by dividing by x, we're going to have d squared y over dx squared, which is equal to x into 3x cubed. That would be 3x squared. X and x squared will cancel. So it's going to be 5x. X and x here will cancel. You remain with -7. So this is what you're going to have. So remember, if you are dealing with such type of second order like this, we are supposed to integrate both sides with respect to x. So if we are to integrate both sides with respect to x, this is going to give us dy dx. So this will be dy dx is equal to, we integrate here. That is, we are going to add 1, which is 3. So it was supposed to be 3x to the exponent of 3 over 3. 3 and 3 cancels. So that means we are left with x to the exponent of 3 plus 5x. We are going to have 1 plus 1, which is 2. So this does not change. So it is going to be 5x squared over 2 minus 7x. Remember, guys, this is just a constant. So we are going to add x plus the constant of integration. So this time I'm going to use a. So you can choose C1, the other one will be C2, C3, and so on and so on and so on. But if you choose A, then the other one will be B, and so on and so on. Okay. So at this stage, we need to find the value of y. So we're supposed to integrate again both sides. So if we integrate both sides again, this will be y is equal to, we add 1, that's to the exponent of 4 over 4, plus if we add 1, this will be 3. So it was supposed to be 5x to the exponent of 3 over 2 times 3, of which 2 times 3, that's 6. So it will be 5x to the exponent of 3 over 6, minus 7x to the exponent of 1. This is 1 plus 1, which is 2. So it's going to be 7x to the exponent of 2 over 2, plus a is a constant, just like 7, it gave us 7x. So a is going to give us ax. But we are integrating both sides, so we are going to have the constant again of integration. This time it is going to be b. So if you use the c, you are going to use as c1. The other one is going to be c2. Okay, so as you can see, guys, that's what we had from these questions. That was question 6, having a total of 7. All of the paper having a total of 100 marks. So these are the typical questions that they can ask you, and you are able, you must be able to attempt these questions. So the only way that I always advise you guys is to work on more questions, more revisions, more question papers, and you actually see that these questions can be attempted without hassles or without strains, but we need to work on much questions as much as we can. So that's it, guys. From Maison African Motives, still on Mathematics N5, till we meet again.